All right, moving on to page 3. This time we're looking at basically a pie chart, and we're asked to find the angles and arc measures according to how this pie chart is broken up in percentages. What's important to remember is that when we're dealing with a circle, when it comes to percent, a full circle is 100%, but when it comes to degrees, we're talking about a full circle being worth 360 degrees. So in a sense, we're setting up proportions, right? So if I want the measure of angle AMD, we're looking for how much of the circle exists within those degree measures within those percentages in terms of degrees. So if this angle consists of 15 plus 5 plus 5%, so we have 25% of our pie here, what we're really saying is 25 out of 100 is equal to how many degrees out of 360. Okay, you're setting up a proportion. So I cross multiply, or I can simplify the fraction and find the equivalent. But point is, I'm looking to solve my proportion. So I have 90 degrees is equivalent to 25% out of 100. Now we want the measure of angle DMB. So while that consists of 40% of the pie, we want to know what that's equivalent to in terms of degrees. So 40 times 360 divided by 100 tells me that that's equivalent to 144 degrees. Next, measure of arc BC. So if BC makes up 30% of the pie, go to the proportion. So 30 out of 100 degrees is equal to how many, 30 out of 100%, is equal to how many degrees out of 360? That gives us 108 degrees are equivalent. All right, last one in this section, measure of arc CBA. So again, what that tells me is I'm going from point C to point A by passing through point B. So all of this accounts for 65% out of 100. So how much is that worth out of 360 degrees? So 65 times 360 divided by 100, that's equivalent to 234 degrees. Next, have some fill in the blanks here. In a circle or in incongruent circles, congruent central angles have congruent chords, technically, and arcs. So there are congruent chords and congruent arcs within congruent central angles. Next, in a circle or in congruent circles, congruent blanks have congruent arcs. That's going to be central angles and chords. Right? All three go together. Number 7, the measure of an arc formed by two blank arcs is the sum of the measures of the two arcs. Well, the only way we're going to really combine or get a sum of two arcs together is when we're adding them together. So by two, and the only way we're going to add them together is when they're next to each other. So formed by two adjacent arcs. So the measure of an arc formed by two adjacent arcs is the sum of the measures of the two arcs, right? This arc plus that arc equals a bigger arc. Number 8, in a circle, the blank of a chord is a radius or diameter. Actually, this question should be crossed out. I'm very sorry. I think there's 2 of them here. This goes to the section that I identified that you could cross out. So sorry about that. Next, in a circle or in congruent circles, congruent arcs have congruents. Well, if the arcs are congruent, then the central angles are congruent. And the chords are congruent. Number 10 also gets crossed out. I'm really sorry. Number 10 gets crossed out. Just ignore it. All right, moving on to number 11. To find the measure of arc IK, I look, and the fact that they're naming with just 2 letters is what identifies that I'm looking between I and K in this direction as opposed to this direction. Minor arcs can be named using 2 letters. Major arcs, the ones greater than half the circle, cannot. They would have to have 3 letters. So I know I'm looking at this minor arc IK, and I know that that consists of 60 degrees plus 90 degrees. So that's a total of 150 degrees. Measure of arc JIL, well, this time I do know I'm looking at a major arc because they do name 3 letters, plus it's telling me that it's going through point I in order to connect J and L. So this is a semicircle, so that's already 180 degrees plus another 60. So when I have 180 degrees plus 60 degrees, that gets me 240 degrees. Okay, next page, we have another pie chart here. So it's another situation where we're looking at the pie split into different percents. So when a full pie is 100%, we also know a full pie is 360 degrees. So we're looking to figure out what is the degree equivalent to the percent we're working with. So in number 1, angle CAB, that's this angle here, which they're telling us makes up 32% of the pie. So 32% is equal to how many degrees? Well, I'm going to cross multiply. When I do, I find that that's equivalent to 115.2 degrees. Okay, question 2. Angle DAG, well, that's actually this portion here that contains all 3 of these angles. That's 18% plus 7% plus 1%. When I combine all of those percents, I get a total of 26%. So 26% out of 100 is equivalent to how many degrees out of 360? Well, when I cross multiply, I find that that's equivalent to 129.6 degrees. And next, measure of angle EAC. So EAC this time consists of the bachelor's degree and some college. So that's 18% plus 17%, telling me that I'm working with a total of 35%. So 35% out of 100% is equivalent to 126 degrees out of 360. Number 4, I'm going to erase all these angle things. Okay, number 4, we're looking for the measure of arc BG. And I know I'm going from B to G in this direction because they used only 2 letters, which means we want the minor direction, the one that's less than half the circle. Had I connected B to G in this direction, I'm clearly far more than halfway around. So I know I'm dealing in this direction, and that's 25%. So 25% out of 100% is equal to how many degrees out of 360? Well, when I cross multiply, I find that that's equivalent to 90 degrees. Next, the measure of arc GF. GF is this little guy in here, this 1 degree. So 1%. This 1% out of 100 is going to be equal to how many degrees out of 360? 3.6 degrees. Last one in this section, we have measure of arc BDE. We know that that's a major arc from B to D to E because they're connecting B to E by going through D. So that's consisting of the 32% and 17% and 18%. So all together we have a total of 67% that we're working with of this pie. And 67%, whoa, a fly just attacked me. 67% of 100% is equivalent to how many degrees out of 360? That's going to be 241.2 degrees. All right, number 7. We're looking for the measure of arc QS. So from Q to S in the minor direction, right, less than 180, and I know that because it's only named by 2, I want to connect these two angles, or these two arcs. So I have to do some, I guess, analysis, really. I can realize that I have vertical angles here. If this is 47, then this is 47. I can see that I have diameters going on here. Well, we already marked that as 47. I have a diameter here, which tells me that all 3 of these angles should add up to 180. So if I subtract if I subtract the 55 and the 47 from 180, I see that this angle is worth 78. And then I know that arc QS consists of the 47 and 78. So when I add them together, I realize that I have a total of 125 degrees for arc QS. Arc RQT connects point R to point T by going through point Q. So I know I'm trying to collect all of this. So we already said that this angle was 47 because it's vertical with the other 47. Now I can also acknowledge I have another diameter over here, so these two should add up to 180 together. I could actually even notice that this diameter tells me from here to here is 180, and then I just need to combine another 47. So 180 plus that extra 47 gives me a total arc measure of 227 degrees. Okay, last one for this video. We want arc HG. So arc HG is this one here. I know that if this is a diameter, all 3 of these should add up to 180. So far we know this one's 23, we know this is 90, so when I subtract those from the total semicircle, I get that this is 67 degrees, which makes that arc 67 degrees. Now arc FEH connects F to H by going through E. From here to here is already 180, plus another 23 gives me a total of 203 degrees. Okay, I'll continue on the next video.